So we're looking at the working of your AC motor now. Sorry, not motor, AC generator. So this is our circuit diagram. We have a magnet, armature, ABCD. We don't have split because it's not split, it is slip. Okay, slip and split, there's a difference. So there are two rings, R1 and R2, connected to B1 and B2 all the time. Those are your brushes. I hope you guys got the difference. It is with this that DC becomes an AC, as simple as this. And yes, we have a magnet producing your magnetic field. So let's understand it with different cases. So when we initially start, this will be our setup, right? Now, if we rotate it clockwise, okay, so this is going up basically, and this is going down. So what happens? Let's have a look at this. So here we have the wire being pushed up. So your thumb is pointing up. Magnetic field is from left to right, left to right. So the index finger will be pointing towards us. I hope you guys did the same. So this is your thumb. This is your ring finger. And this is your middle finger. So this indicates motion or the force. Ring finger indicates the magnetic field. And your middle finger indicates current. Okay. Now, when it comes to CD, it is pointing downward. Magnetic field is right to left, right? So let's see what happens. So we have your middle finger pointing outward. Again, I hope you guys are doing it. If not, there's no point in all of it. This is for your own practice. So let me write. So thumb is downward, then you have ring finger, and that's your middle finger, right? So this will indicate that current is going away from us, and this is towards us. So here you have current in what is this? Anti-clockwise direction. So let's see what is happening, which end is what. See, if I follow, current supposed to be coming from this end, right? Cutting through this. Okay, so don't think too much. How is this passing through this? You can design it. It's not a big deal. So from ring 1, you have CD running and going to ring 2. So basically, your brush 2 is positive and brush 1 is negative. That's when you have it at 0. So when it's flipped half the way, the magnetic field though won't change. Now, let's see what is happening along AB. So here it will continue, the system will continue to rotate in clockwise direction itself. So this is going down and this is going up. So we have thumb pointing downward for AB, length C. We are looking at length AB and length CD over here. So what is happening with each length? That's how we will understand what is happening overall. So we have thumb down, magnetic field is from right to left. So what happens? As per your Fleming's right hand rule, the middle finger, this is thumb, and that's your ring finger. So indicating force, that is motion. This is your magnetic field, and that's your current. Motion, magnetic field, and that's your current. Right. So here the current is going away. Here the current is coming towards. It's the same thing. Same as what? Same as AB. Right. In the case 0 degree. So this is what we will see. So this is coming towards us. So let's see what happens. Ring 1, since we have current going away from us, is positive. And in ring 2, since the current is coming towards us, so that's where it's terminating, means what? It's negative. Can you see that? the roles have switched, right? That's your AC, that's it. Okay. So to summarize, we have current going up and down. So when the coil rotates 90-degree, it is at kind of peak in the graph, that is 180-degree it's 0, 270-degree it's negative, right? 360-degree it's back to the original place. So one complete revolution. In the first half, we have one of the brushes to be positive. The same brush is negative in the second half. Okay. So we're talking in perspective of the brush or the direction of current in the circuit. Anyhow, whatever you guys want it. So one of the brushes will be positive and the same brush is negative in the next half. Again, positive, negative, positive. So this is how it will move. So please understand this. This is one complete revolution from 0.0 degree to 0.360 degree. So this is not current versus time. This is current versus the rotation, not in degrees. Actually, this is supposed to be rotation, armature rotation in degrees. Rotation of armature. And this too is rotation of armature. Okay. Right. So how does this is in perspective of one of the brushes, the fluctuation. We can take it as B1. No, this is B2 now. B2 was positive. Now, when we look at the movement of the electron, so the movement of the electron will be going in, say, away, then towards, away, and then towards, right? So actually, this is not rotation now. This is time. No, rotation only of the armature, correct. Anyways, this is just a different perspective, but yeah, all of this is happening simultaneously. It's the same thing, but different names. Okay, I hope you guys understood how an AC generator works. It's the same setup as your DC, but instead of split, you have slip. And I hope you guys understand why is it slip, not split. Right? R1 is always in touch with P1, R2 is always in touch with P2. So they switch roles of becoming negative and positive in every half a cycle. Right? Make sense? So this is your write-up. Not write-up, sorry. This is your working explanation and everything. So you guys can pause and copy it off. Very important slide. So here the current continues to be in the same direction though. But B1 and B2 changes the roles. So this is half a revolution from 0 to 180 degree, 0 to 360 is one complete revolution, right?